Hi everyone and welcome to eSchool Bell. Now we will do question number 14 from exercise 7.8 of CBSE class 12 chapter 7, which is integration. In this problem, within the definite integrals from 0 to 1, we need to integrate 2x plus 3 divided by 5x square plus 1 dx. Okay. Now before we proceed with the problem, if you see, the numerator is 2x plus 3 and the denominator is 5x square plus 1. This is a standard form, this is a standard form. Okay, when standard forms are separate, we can directly integrate them, but when they are together, here in this case one above other, then it is very difficult to integrate them directly. So the best way to integrate such problem is by substitution. Yes, substitution. We will use substitution method. In this method, either the numerator or the denominator, we will substitute as some other variable as t. So in this case, we will use the denominator 5x square plus 1 is equal to t. Some of you might ask why we are using the denominator as t, why not the numerator? Because after you do the substitution, then you are going to do the differentiation. When you do differentiation of 5x, you will get 10x dx, which will be coming close to the numerator value. Okay, so basically a higher power value we normally put in a substitution so that we get after differentiation the lower power value. Okay, so that is why we will take the denominator as t. So once you differentiate it, you will get 10x dx plus 0 is equal to dt, or x dx is equal to dt by 10. If you see, for this particular problem, this is substituted as t. Now you have x dx, but you don't have 2. So for this reason, we'll put 2 here and 2 here. Okay, so the next step will be 2x dx is equal to 2, this is 5 times, will be dt by 5. Okay, so in place of this 2x dx, we can put dt by 5. Now the only odd term remaining is 3. Okay, so we have a plus sign in between, therefore we will separate them out. Okay, so the next step here will be integral 0 to 1 2x divided by 5x square plus 1 2x dx plus integral 0 to 1 3 dx divided by 5x square plus 1. Now this entire term can be substituted as t and dt by 5, and this one we need to use this formula. Okay, this is the integration formula, so we will use this formula and then get the solution. So next step will be, and also the other thing is, since we are going to use substitution method in this, so here the limits are basically with respect to x. Now we have to find limits with respect to t. Therefore when x is equal to 0, 5x square plus 1 is equal to t will be 5 into 0 plus 1 is equal to t, and t will be equal to 1. When x is equal to 1, 5x square plus 1 is equal to t will be 5 into 1 square plus 1, that is equal to t is equal to 6. So the new limits will be 1 and 6. So here the next step will be from integral 1 to 6, 2x dx is written as dt by 5 and 5x square plus 1 as t, plus integral 0 to 1, 3 we will take it outside, and also 5 I will take it outside. It will be dx by x square plus 1 by 5. Okay, now remember, the limits here are with respect to x, the limits here are with respect to t. So this will be equal to 1 by 5 into log of modulus t from lower limit 1 to upper limit 6 plus 3 by 5 into integral 0 to 1 dx by x square plus 1 by root 5 the whole square. Now this has come more or less this form. So not more or less, is actually that form. So this will be 1 by 5 into log 6 minus log 1 plus 3 by 5 into 1 by a, that is 1 by root 5 tan inverse x by 1 by root 5. Then the limits 0 to 1. This is equal to 1 by 5 log 6 by 1. See, we know that log m minus log n can be written as log of m by n plus 3 by 5 into root 5 tan inverse we'll take root 5 out, so tan inverse root 5x and limits 0 to 1. This will be 1 by 5 log 6 plus 3 by root 5 into root 5 into root 5. This 5 is written as root 5 into root 5 into tan inverse 5 into 1 minus tan inverse, okay, root 5 into 1, root 5 into 0. The last step, this will be 1 by 5 log 6 plus 3 by root 5 into tan inverse root 5. This will be the answer. This one will become 0. Tan inverse of 0 equal to 0. Okay, this is the solution. Hope you got it. Okay, and we'll see you in the next question. Thank you so much.